so this is a density problem with multiple parts. So this is a relatively longer problem. But first we have to recognize that it's a density problem because one, we do have a density conversion factor, right? Two, we have mass. And then three, we have some sort of volume, right? Because there's length, width. It's a rectangular sheet. It says something about thickness, okay? So first things first, let's write down the formula of density, which is mass divided by volume, okay? We have the density, right? Which is the 2.70. We have a mass, which is 864 milligrams, right? Sorry, this is 2.70 grams per centimeter cube. And we have a length. Remember, volume, at least for a rectangular sheet, would be length times width times height. In this case, times thickness, right? So we are given the length, we are given a width, and then it's asking us to look for the thickness. Let me put X for that one. Okay, so this is finding X, right? Now, the other thing too is that we have our mass in milligrams. Our density conversion factor units are in grams. So to make things easier, it's probably better if we convert the 864 milligrams to grams. All right. If you look at your metric conversion factor table, 1 gram equals 1,000 milligrams, right? We have 864 milligrams. We need the given unit in the bottom, the desired unit on top. We cancel out the units. We end up having grams as our unit, which is what we want. And then we calculate 864 divided by 1,000 is 0.864 grams. Okay, let's rewrite that. .864 grams over 8.0, 4.0, and X. Okay. Now, in order to solve for X, right, we have a fraction, so we probably want to cross multiply these so we can eliminate that fraction. This is 2.70 over 1. We can write that as that. So now we multiply 2.7 times 8 times 4. And we get 86.4, right, times X, because we do have that X down there as well. And equals 0.864 times 1, which is 0.864. Okay. We're solving for X. So we divide both sides by 86.4. Our X is 0.01 centimeters in this case, right? If you want to work out the units, let's go over here. Because we do have 270 grams per centimeters cubed. and equals, we have our grams on top. And then we have these two are centimeters, right? So centimeters times centimeters, you would end up getting centimeters squared. Okay. So we can cancel these out because we do have grams on both numerators, right? And then here we can only cancel out 2, right? So we end up having 1 over centimeter, 1 over centimeter left. And it equals 1 over x. Okay. Now, that gives us the centimeters unit for x. We don't have that on our list of options here. We do have a bunch of millimeters here. We can try, because it's probably going to be most likely in millimeters. We can try to convert the 0.01 centimeters into millimeters. Okay. There's a shortcut for this one, but I did teach you guys to go through the base unit, so we'll do that. It's a longer process, but it's a surefire way of finding our answer in millimeters. Okay, so our base unit in this case is meters. So we know that we have 100 centimeters in 1 meter. Okay, and we have 1,000 millimeters in 1 meter. I can cancel these. I cancel those. So I end up with millimeters. So that will be 0.01 times 1,000 divided by 100. I get 0.10 millimeters. Okay. Note that we do have 2 significant figures because the smallest number of significant figures would be a 2. Okay. And so our answer in this case would be B.